we have the concept of multiplying a row by a column. Very simple concept. Very easy to do. Okay. Example, the row 2, negative 3, 1 multiplied by the column 1, negative 2, 3. To multiply the row by the column, we simply match up the first number in the row by the first number in the column. So we're going to match up the 2 with the 1. We're going to say then that we start the process by multiplying 2 times 1. Okay? Then we match up the negative 3 and the negative 2. Now I'll just write out negative 3 times negative 2. And we'll circle these in green to show that those are the ones that are matched up. And then we multiply the 1 by the 3. And what do we do with those products? We add them. Very simple, we just add. And when we do that, we find that we get 2, 6 here, 3 here. And if I can do my arithmetic right, you got to watch me on that, that's 11. Okay, very simple. Okay, nothing to it. Okay, now, we can't do this if the row doesn't match the column. If we don't have enough numbers in the column to match up with all the numbers in the row, not defined. If we don't have enough numbers in the row to match up with all the numbers in the column, it's not defined. It just doesn't exist. We don't do it. Okay, well, we apply the same thing to this row and this column, and we get 4 times 12 plus negative 3 times 16. 4 times 12, negative 3 times 16. Notice that this row and column are shorter than this row and column, but the numbers match up. We can match the numbers up 1 to 1. Numbers in the row and numbers in the column pair up perfectly. And as long as that's the case, it doesn't matter how long the row and the column are, as long as they're the same length. Okay, well, let's see. We can finish this calculation. Looks like we get 48 minus 48, which is 0. Now that's kind of a special thing. It's going to turn out that if multiplying the row by the column, if the row represents a vector, 4 units in the x direction, negative 3 units in the y direction, and 12, 16, a vector that's 12 units in the x direction, 16 units in the y direction. So this vector's down like this vector's up like this. These things will add up to 0. In other words, the row times the column will add up to 0 if and only if the two vectors are perpendicular, or orthogonal if you want to use the more general term. Okay, we don't need to know that right now, but I thought I'd mention it. You can test that out. Okay, you can make the triangles defined by these two vectors, use the laws of cosines and so forth, or whatever technique you want, trigonometric technique, and you're going to get it. You're going to find that the angle between them is 90 degrees. Okay, another example, just with symbols. Alpha 1, alpha 2, alpha 3, alpha 4 constitute a row. Beta 1, beta 2, beta 3, beta 4 constitute a column. The sum is just going to be alpha 1, beta 1. Okay, then alpha 2 is going to match beta 2. Alpha 3, beta 3, and alpha 4, beta 4. Now if we have numbers If we know what these numbers are, we can do the multiplications and add them up. If the sum turns out to be 0, we're going to say that these vectors are orthogonal in four-dimensional space. Now we can't visualize what that means, but we're still going to say they're orthogonal. It's kind of an important idea, and we'll do more with it. Okay. Now, what you really have to remember is just how you do this. Definition. If you want to write a formal definition, I can write it in terms of alphas and betas. I can say that alpha 1, alpha 2, alpha 3, and so forth out to alpha sub n. So that there are n. Number of the alphas, there are n of them. Okay? Multiplied by the column beta 1, beta 2, and so forth. And we have to have n of these also, beta n, is equal to alpha 1, beta 1 plus alpha 2, beta 2, plus etc. until we get up to alpha n and beta n. And of course in summation notation, which you should be familiar with, unless you're taking this course really early, something that I think should be done in pre-calculus, but it's often not seen until your second semester of calculus. So if you happen to be taking this course simultaneous with the second semester of calculus, you might not understand the notation, but hopefully you will. We could write this as the sum from I equals 1 to n of alpha sub I, beta sub I. And this just means is you're summing these up. I starts at 1, so if I is 1, you have alpha 1, beta 1. Well, just like this. And then I goes from 1 to n, so if after I is 1, the next I is going to be 2. I kind of stands for index, okay? The index would be 2. The index goes from 1 to n. So when the index is 2, you have alpha 2, beta 2. And it's a sum. This is a summation sign. So you do a plus alpha 2, beta 2. And what's next? Well, the index goes to 3, assuming n is at least 3. And you have alpha 3, beta 3. And you keep going until you get up to n, whatever it is. If n is 793, then your last term would be alpha 793, beta 793. And you'd have 793 numbers to add up. Then, of course, you would use technology to do a sum like that. You wouldn't do it by hand. Okay, that's a definition of row times column. And that's going to lead us to the idea of a matrix product, and that's coming up next.